Welcome to the Exec Exchange, 15-minute podcast in which a leader from the water sector shares a story to inspire, inform and educate other water sector leaders from around the globe. My name is Piers Clark and my guest today is Mehul Patel, the Executive Director at Orange County Water District in Southern California. Mehul, brilliant to see you.
Good to see you, Piers.
Now, what we're going to talk about today is the GWRS, the Groundwater Replenishment System that you've been running at Orange County Water District for the past 20 years or so. But before we get to that, let's start with a potted history on your background. So tell me, how did you get into the role that you're in now? What were you doing before?
Yeah, so I got into this role very early on. So while I was getting my master's degree or in graduate school, a professor at the university I was going to asked for volunteers from the class. If someone wanted to volunteer to do some unpaid work at the Orange County Water District, and only two of us in the class raised our hand. And and the first question I asked was, if I do this work for free, will it count towards my thesis? Because I don't have any ideas. And she said, yes. So I said, I'll take it. So I started doing some lab experiments for who would turn out to be my boss later on, Greg Leslie, an Australian, who was here to run some of our early applied research for what would become our groundwater replenishment system. So I started as a unpaid intern, and then they decided to pay me for a little while, and then decided to go on a couple of short-term contracts. And then once the project kind of started to move along, made me permanent, and then worked my way up to an executive over the course of the years. So this is my 30th year, basically, since that first unpaid internship.
Well, it sounds like he's given you lots of exposure in different parts. So the beauty of being in the water sector is you can move around and reinvigorate your career with different challenges. I have to ask, though, Greg, the Australian that you mentioned, at some stage, I assume you leapfrogged him and you became his boss. How did that go down?
Interestingly, in 2000, he decided he wanted to go back to his native Australia. And so I ended up taking over his position and running the rest of the applied research. And it's almost a full circle story because he ended up working for the old CH2M Hill, now Jacobs, and did some early designs on the Singapore Newater project, especially the Kranji plant. So he was kind of still involved in reuse for a long time and is now a professor at University of New South Wales in Sydney. He really taught me a lot, but also saw a lot in me, which maybe I didn't myself. So he was a good mentor at the beginning as well.
Excellent. Now, for people who don't know about Orange County Water District, where are you? What sort of activities do you do? How many people do you serve?
Yeah, so the Orange County Water District's in Southern California in a city called Fountain Valley, about 30 miles south of Los Angeles. We're what's called a special district, and we were created by the state of California to specifically manage the Orange County Groundwater Basin. So there's a naturally occurring groundwater aquifer in our service area that we manage. You can consider us like a groundwater wholesaler. So we sell groundwater to 19 municipal water agencies, and 2.5 million people rely on this groundwater basin as their main source of drinking water. So it's our job to make sure it's sustainable and safe from contamination. And we have to find various sources of water to replenish that basin to keep it sustainable long-term.
Well, we're going to come to that now. Because anyone who's got any familiarity with Southern California will have seen the news that says, well, the Colorado River sends all its water down to California and you drink all that. But you've been talking about groundwater recharge, and that's because you get a lot of your water from groundwater recharge. So let's talk about what is the groundwater replenishment system? When did it start and why did you instigate it?
So the groundwater replenishment system went online in 2008, but the planning had started as early as 1999. It's a large advanced water treatment facility, along with other peripheral pieces like additional injection wells, distribution pipeline. But the scheme is meant such that we can take treated wastewater, secondary effluent that's produced by another agency called the Orange County Sanitation District, who has the same service area, but their main purpose is to treat, collect, and dispose of wastewater. And they would normally send their secondary effluent or their treated wastewater to the ocean for ocean disposal. When we decided to partner on this project, we were going to produce at first 70 million gallons a day of purified water. That's what the plant was sized for originally in 2008.
Which was how much in terms of the proportion of wastewater they were generating?
When we first went online at the 70 million gallon per day mark, we were taking about half of the flows that they produced. And they have two big wastewater treatment plants. And then the plant was always designed to have expansion in mind. So piping was oversized, room was left for additional equipment. And the scheme was to take the secondary effluent and put it through what California calls full advanced treatment. So microfiltration, ultrafiltration, followed by reverse osmosis, and then followed by advanced oxidation. In our case, using ultraviolet light with hydrogen peroxide. And when we first went online in 2008, the regulations around indirect potable reuse, especially for groundwater recharge, hadn't been finalized. So we had proposed this treatment scheme and had gotten regulatory approval. And then later in 2014, regulations were finalized and they actually called for full advanced treatment. They defined it as a low pressure membrane process, RO, and advanced oxidation. So we were a little bit ahead of the curve, at least at that time. And the whole point here is to take the secondary effluent, treat it to beyond drinking water quality, and then inject it along the coast to prevent seawater intrusion, because our aquifer is a coastal aquifer, so it's hydraulically connected to the ocean through naturally occurring fault lines. This is a geologically active area for earthquakes and natural faulting, and most of Southern California coastal aquifers have connections to the ocean that way. And then the majority of the water, we actually send it 15 miles north or inland from the coastal treatment facility itself to an area where the geology allows for just surface spreading, where we can accumulate the water in a series of lakes that we own, and it'll naturally seep or drain down through the soil matrix right into the principal aquifer. So the goal is to have additional source of water that can be used for not only protecting the aquifer from seawater intrusion, but become another major source of replenishment beyond the traditional sources that we've had previously.
Brilliant. And as of today, all things being equal, i.e. no operational issues, you take 100% of the wastewater effluent that comes out of OC San, goes into the GWRS.
Yeah, so that's one of the things that we're most proud of, is that we now take all of the treated wastewater that's recyclable in our service area and put it to beneficial reuse, in this case, replenishing the aquifer. And that's been a long-term goal of the Orange County Sanitation District as well, is to have most of their effluent, in this case, all of it that can be recycled, have it recycled and minimize the amount of ocean disposal going forward. And so we were able to meet both agencies' needs. The Orange County Sanitation's needs to have a more environmentally friendly operation and reduce pumping costs to the ocean. And then for us, maximizing this new source of water to help meet the growing demand in our service area, while also mitigating other sources becoming either less available or more erratic or escalating in cost, especially imported water.
I assume someone's done the calculations to work out how many times the water goes round.
Yeah, so the way to think of it is, obviously it's not 100% efficient. There's some losses along the way in the treatment process and the way the water gets replenished to the groundwater aquifer, but you can think of it as an unlimited cycle. That's what we kind of say to people that come for tours. It's really the same water. Consumers use it, ends up in a wastewater collection system, goes to the wastewater treatment plant. There's some losses there, comes to us, some losses there. But for the most part, that water then goes right back into the aquifer, mixes with native groundwater, and then pumped back up again for use, and the cycle continues. So the hope is to have a somewhat closed loop system, but being realistic about losses along the way that are a normal part of the treatment process.
So this is not only the longest running, but I believe it is the world's largest indirect potable reuse scheme, which is a staggering claim to be both the largest and the longest running. You wouldn't normally have that happening for something so innovative. Now, how do you make sure that the contact time between injecting down the wells and drawing it out is appropriately lengthy?
Yeah, so the regulations require a minimum of 2 months of underground travel time, depending on the level of treatment. In our case, we require 4 months of underground travel time. So what we've done is two things. We did originally do a chemical tracer before the original plant came online in 2008, but we also have an extensive groundwater computer model that our hydrogeologists run. So we were able to run some simulation and some modeling to show the travel time, and then back that up with what we call a natural tracer, something really simple. We use chloride. So if we detect chloride in low concentrations, we know it's the presence of our ultra pure water from the groundwater replenishment system. Or conversely, if it's high, we know that's an area where seawater intrusion has started. So it's a good natural tracer. Regulators really like that, instead of introducing some sort of chemical to act as a tracer.
What do you know now that you wish you'd known when you started this scheme?
Oh God, there's a lot of things, but I think the main thing is I wish I would have known how much effort it was going to take to move the project forward, and the time frame was going to be so compressed.
Is that because of public perception around wastewater recharge? Was that the issue?
Yeah, at the beginning, there was a huge public perception issue because there had been 2 previous projects in the local area, one in the city of Los Angeles, one in the city of San Diego, that were defeated through negative public opposition. So the original San Diego Pure Water project and then the East Valley project. So we spent a lot of time up front on an outreach plan, one where we changed the mold from we build these projects because we need it and then do some outreach once it's online, to being very proactive and being open and honest about its wastewater that we're treating and making it to beyond drinking water, and why. And most importantly, starting with why is there not enough water in our service area? Traditionally, we've taken for granted that there's plenty of water in Southern California. And I think the average consumer, this was in the late 90s especially, didn't know that water was imported. It was mostly imported, and that this was a near desert climate. I think they took for granted that, it's a pretty green area. You come to Southern California, everybody has a pool and a lawn and lush landscaping, but most of that is from imported water. And we wanted to educate people that there's areas in Southern California where we can't continue to rely on imported water. And even some of the natural sources suffer from the same thing that the Colorado River does, which is extreme drought cycles. And we need to have other options.
It's even more telling because, of course, it's not like you had many other choices. If you hadn't done this project, Orange County wouldn't be a functioning, thriving community as it is today. What was the alternative? A desal plant?
Our alternative would be to start doing mandatory restrictions on the use of groundwater, which again would limit business growth, would limit our economy, more importantly, limit our growth in terms of urbanization, because this is a heavily residential area. I think you wouldn't have the thriving economy you have today without a reliable source of water. And in this case, a groundwater basin that can be replenished with multiple sources.
Well, it's been terrific hearing about this project. And actually, I had the joy of visiting your site as part of the study tour that we organized for a number of Vorti a few weeks ago. So it's brilliant to reconnect with you. Now, we normally finish with a question about what advice would you give your younger self if you could go back in time. But before you answer that, we're doing this as a Teams call. And I see behind you a whole array of football, soccer, for those in America, memorabilia from Brighton and Hove Albion to Manchester United to Sevilla FC. Before we get to what advice would you give your younger self, and noting that we have the World Cup coming up very soon, tell me about the football memorabilia.
Yeah, so I grew up a football fan, played it all my life, even in high school, was going to play in college, but got injured. And every time I visit Europe, I always want to see a match. I've been to Spain a lot, and there's nothing like seeing it in person. So every time I go, I try to collect a scarf if I can. In fact, I just got back from Madrid, so I went to an Atletico Madrid game.
Oh, nice.
Got another one. I got to see a famous player's last game, Antoine Griezmann. That was his last game at Atletico, so they did a nice ceremony. Yeah, it's just something I enjoy, and with the World Cup coming, it's going to be even more impressive, and hoping to go to a match here in Los Angeles, SoFi Stadium, so it'd be nice to see one. I remember when the World Cup was here, and I believe, 94? Always watching it on TV, but I was much younger. But now maybe a chance to see it in person would be great. Yeah.
Excellent. All right. Well, that's good. Thank you for sharing that. Let's come to that final question. What advice would you give your younger self?
The number one advice I'd give my younger self is to never stop learning and try to learn as much as you can along the way. I've been fortunate at OCWD that one of the things that they promote here is if you want to try something new, even if it's in another department, or you want to work on a project, if you show an interest, they'll allow you to do it. So I think that's good advice for anyone, is you can't be afraid to try new things, learn new things. If you just do what you're told all the time, you can never progress. And in this business, there's a lot to learn. And as you know, the water industry is a small world. Everyone knows each other. So you might as well learn as much as you can and outreach with as much people as possible. And it not only enrich your career, but enrich your life, because at the end of the day, we're doing something very beneficial to society. We're trying to make life sustainable here in Southern California.
You have been listening to the Exec Exchange with me, Piers Clark, and my guest today has been Mehul Patel, the Executive Director of Operations at Orange County Water District in Southern California. And we've been talking about the Groundwater Replenishment System, the GWRS, and I hope you've enjoyed it. I hope you can join us next time. Until then, keep asking questions, keep sharing, and keep safe.